Hello everyone, I'm SJBIT, working as Assistant Professor in the Department of PC SJBIT. In this lecture, we'll be discussing about computer organization and architecture.
So as you know, the memory is basically which is going to store a bit of data. If I say the memory cell which can store one bit of data. So the maximum size of the memory that can be used in any computer is determined by the addressing scheme. For example, if you take the 16-bit computer that generates the 16-bit addresses is capable of addressing, that is 2 to the power of 16. So that is equal to 64K memory location. Similarly, if you consider 2 to the power of 32, that can store 4 giga memory locations. Whereas the machine with 40-bit addresses can access up to 1 tera, that is 2 to the power of 40 is nothing but 1 terabytes location. So we always evaluate memory in terms of 2 to the power, not to the 10 to the power of bytes, because we consider all the memory which can store 1 bit data at a time, which is in the form of bit. That's why we should consider the base is always is equal to 2. So the number of location represented the size of the address space of the computer. So the why we say that is 16-bit, 14-bit or 32-bit processor is nothing but 32-bit processor is nothing but it is going to store the memory location allocated to store the program is 2 to the power of 32 means 4 gigabytes. That is the memory address location of that particular processor. So this memory can be extended. This is, we say, the main memory of the computer system. It can be extended by using the disk drives. Okay, so the modern computers are byte addressable. As shown, you are able to see the figure. So which is going to shows that is the assignment of a byte addressable, that is a 32-bit computer system. So the big Indian arrangement is used in the whereas the 68,000 processor. So the little Indian arrangement is used in the Intel processor. So big Indian is nothing but the address is going to be decreased from higher order to the lower bytes, whereas the little Indian is nothing but the address is going to be in increasing order. So that is a lower order higher bits to the higher order bits. So that is the difference between the little Indian and the big Indian. So the memory is usually designed to store and retrieve the data in word length quantities. So the fact that the number of bits actually stored or retrieved in one memory access is the most common definition of the word length of a computer. So consider, for example, if I say a byte addressable computer whose instructions generate a 32-bit address. So when a 32-bit address is sent from the processor to the memory unit, as the higher order of the 32-bit is determined which word to be accessed. If a byte quantity is specified, so the lower order 2 bits of the address is specified which byte in that particular location is involved to read. So that is going to be identified. So if I say the read operation, so the other bytes may be fetched from the memory, but they are ignored by the processor. So if the byte operation is right, however, the control circuitry of the memory must ensure that the contents of other bytes of the same word are not changed. So if it is going to retrieve some from other memory location that is not related to the related to the execution of the program, so that can be discarded by the processor. That should not happen. It has to retrieve the proper address, I mean proper data which is been stored in the particular address which is specified by the processor. So you are able to see the figure. So there are, the processor has two registers, one is MAR, the other one is MDR. So what is MAR depicting? It is the memory address register. What is MDR depicting? It is a memory data register. So if memory address register is k bit long and the MDR is n bit long, it depending on the processor, it need not be the same that address bus is equivalent to data bus. So data bus and address bus may vary depending on the configuration of the processors. Okay, so then n bit long, then the memory unit may contain up to 2 to the power of k addressable location as is specified earlier. So the it is nothing but 2 to the power of k is nothing but the number of bits long, that is the MER is going to have. So it is going to addressable how many location? It is 2 to the power of k. So during the memory cycle, the n bits of data are transferred between the memory and the processor. So you are able to see the diagram. So where the address bus is always unidirectional, it is only going to direct. So MDR is going to be a bidirectional data bus. So which is going to which is going to read from the memory as well as it is going to write from the memory. So the last signal what you are able to see is the control signal. What the bus also includes the control lines, read or write, and the memory function is completed, that is MFC, for coordinating the data transfer. So other control lines may be added to indicate the number of bytes to be transferred. So the connection between the processor and the memory location as shown in the figure. Okay, so the processor reads the data from the loading by the address of the required memory location into a MER register. So the processor reads the data from the memory by loading the address of the required memory location into the MER register and setting the read or line to is equal to 1. So the memory respond by placing the data from the addressed location to the data lines. The confirm this action by asserting the memory function complete signal. So upon receipt of the MFC signal, so the processor loads the data on the data lines into the MDR register. So the processor writes the data into the memory location by loading the address of this location into a memory address register and loading the data into MDR. It indicates that a write operation is involved by setting the read or write line is equal to 0 is nothing but the W bar is indicating active low signal, the R is indicating active high signal. The same signal can be utilized for the two operation, read as well as write. Whenever the signal is active high, it is for read operation. Whenever this signal is going to be active low, then that is for the write operation. So next, so the memory access may be synchronized by using a clock and they may be controlled by using the special signal that control transfer the bus using the bus signaling scheme. So as described, that is the memory read or write operations are controlled by input and output bus transfers respectively. Another important that is nothing but you are able to see on the screen, that is it measures for the speed of the memory, that is the one is known as the memory access time, the other one is known as the memory cycle time. So what is the memory access time? So memory access time is a useful measure of the speed of the memory. It is going to use to measure the speed of the memory that elapses between the initiation of operation and the completion of that particular operation. For example, if I say the read operation is going to be initiated by generating the read signal to another signal is going to be high, that is the memory function complete signal is indicating the high signal. So this is referred as the read and the MFC signal. When it is going to make MFC signal as high, then it completes the entire duration. It is known as the memory access time. So another important measure is the memory cycle time. What is memory cycle time? Which is the minimum time delay required between the initiation of two successive memory operation. For example, if we say the two successive read operation as indicated by the processor to the memory, so the certain to complete that is one read operation should be completed and another read operation should be initiated and that has to be completed. That is nothing but the memory cycle time. The cycle time is usually slightly longer than the access time. So depending on the implementation and the details of the memory unit. So the next is known as there are two types of memory in case we say, that is the RAM memory, that is the random access memory. So what is random access memory? If any location to be accessed or read or write operation, some fixed amount of time is independent of the location address. So the access time on the later device depends on the address or the position of data. So another memory that is an important design issue to provide the computer system with a large and fast as a memory as possible within the given cost of the topic. So there are several techniques to increase that is the effective size and the speed of the memory. The one is the cache memory, the other one is the virtual memory. So why we go for cache memory? Why we are not bothered about? Why though the main memory is available, why we have go for another two memories? So as soon as the processor going to instruct fetch that particular data or the instruction, the where the memory location is stored, it been sent to through the MER. So the access time is going to be longer, as I mentioned earlier also, that is memory chip is going to be not going to be placed inside the processor, but it is going to be placed outside the processor. So that's why it has to send the signal through a bus and retrieve the data from the bus. It is going to take a longer time. So for that reason, short memory which can be used in between the processor and the memory, so that already it been like a buffer. If it is stored in the cache memory, then it is easy to access the to the processor to retrieve the data without spending much time. So there are several techniques increases the effective size and the speed of the memory. So one is known as a cache memory to increase the effective speed. Another one is known as a virtual memory, that is to increase the effective size of the memory. So what is cache memory? The memory cycle time, that is the processor of a computer can usually process the instruction and the data transfer that can be fetched from the reasonably priced memory unit. So the memory cycle time, then it is the bottleneck in the system. One way to reduce the memory access time is to cache memory. This is a small memory, or you can say the faster than the main memory, that is inserted between the larger slower main memory and the processor. It holds the currently active segment of a program and their data. So it holds the currently active segments of the program and their data. So another type of memory, it is known as the virtual memory. So virtual memory is another important concept related to the memory organization. So far only we have discussed the address is generated by the processor directly specifying the physical location of the memory. When it is not present in the main memory, it is other than the main memory, which is we consider as the disk storage. So that is the memory that is semiconductor memory is costlier to implement, because it is a costlier device which can be, if you implement in a larger size, so the automatically the cost of the system is getting increased. So because of that reason, to reduce the cost, the computer design in such a way that the main memory is used as a semiconductor memory, which is going to have a small, some amount of data can be stored. If it is in large in size, so then it can be stored in the other than the main memory, which is considered as the disk drives. Okay, so the all other that is a booting step, the operating system is going to initiate all these memories. So where the address is going to be generated virtually for the disk storage memories content. So that is known as the virtual memory. So virtual memory is another important concept related to the memory organization. That is the data may be stored in the physical memory location that have accessed different from those specified by the program. So the memory controller circuitry translates the address specified by the program to an address that can be based to access the physical memory. So in such cases, the address is generated by the processor. It is known as a virtual or logical address. So virtual memory is mainly used for increasing the size. So the memory system, we have two types of, the memory system, as I mentioned, one is the semiconductor RAM memories. So there are two types basically we go for the memories. One is the RAM, other one is the ROM. RAM is nothing but you can read and write. So that's why it is known as a random access, and it is also a volatile memory. If you come for the ROM, it is a non-volatile memory, only it can store, we can retrieve the data, not we can store it. It's once it's stored, finished. So read and write is not possible in case of ROM. So the memory system using the semiconductor RAM memories. So the internal organization of memory chips. Each memory cell can hold 1 bit information. So memory cells are organized in the form of an array. So one row is one memory word. All the cell of a row are connected to a common line known as the word line. Word line is connected to the address decoder. Sense or write circuits are connected to the data input or the output lines of the memory chip. This is what the internal organization of the memory chip you are able to see. So how many address lines here? A0, A1, A2 and A3. That is the 4-bit address lines. Is nothing but it can address, that is to the power of 4 is nothing but 4. It is going to have 16 locations. That is from W2. What is the word length? Word is going to have 16 words, that is 0 to 15. What is the word length? Word length is going to be depending on the database. So what is the database capacity? So you are able to see here, this is the data input and output lines. So the data capacity is going to be from B0 to B7. So 7-bit data bus and 4-bit address bus. So what you are able to see, this is what the semiconductor memory cells you can say. So say why it is known as the semiconductor memory cells? Because it is going to be used the semiconductor material. For in this cell they are going to use the semiconductor materials. Okay, so you are able to see that is the word length is going to be equal to 17 bit. Sorry, 7 bit. Sorry, 0 to 7 is nothing but 8 bit is the word length, and you are able to see whenever the word length is depicting is nothing but it is going to directly connected to the data bus. So what is the data bus capacity? Data bus capacity is also going to be 8 bit. So one more circuit you are observing, sense or the write is nothing but this cell has to be, sense is nothing but read operation, write is nothing but write into the cell, that is nothing but the write operation. How this is going to be controlled by? So these are going to be controlled by read or write bar signal. So as I mentioned, when it is active low signal it is for write operation. Whenever it is for active high signal it is for read operation. And this is what the chip selection, the particular word in that particular column, particular row, particular column should be selected. How it is getting handled? It is getting handled by the chip selection switch. Okay, so now the memory cell usually organized in form of an array. So as I mentioned, the each row of cells consisting of a word, and all cell row are row connected to the common line referred as the word line. So cell in the each column are the sense or the write circuit by the 2-bit lines. Sense or the write circuits are connected to the data input or output lines of the chip. During the read operation, these circuits sense or read information stored in the cell selected by the word line and transmit this information output lines during the write operation. So the sense or write circuits receive input information and stored it in the cells of the selected word. So this is the figure is depicting that is the 16 into 8 organization. 16 is nothing but it can 16 address location, each location can store 8-bit data. So data inputs and the data outputs of each sense or write circuits are connected to a single bidirectional data line that can be connected to a data bus of a computer. To control lines read or write on the chip selection are provided in addition to address and the data lines. So the read or write input specifies as the required operation, and the chip selection input selects a given chip in a multiple chip memory system. So here you are able to see that is 128 bits requires 14 external connections for the address data and control lines. So consider a slightly larger memory unit when it is addressed to be, store has to be 1K, that is 1024 memory cells are required. So this circuit can be organized as 128 into 8 memories, nothing but 128 bit into that is a memory location into 8 memory. So that is going to give that is requiring 19 external connections. Alternatively, some other the same number of cells can be organized into 1K into 1 format. So in this example, if it is the 10-bit address is needed, then it can store only one data line and resulting 15 external connections. 10-bit is for the address lines, 1 bit for the data lines, and 4 more external connections, so that is for the read and the sense or the read or write or the chip selection circuit. So in this memory, that is 8 data lines and 4 address lines is nothing but 16 memory locations into 4. So it is going to have the 4 address line plus 8 data lines is nothing but 12. 12 plus 2. So it is 14 external connection which is required. So in this figure, you are able to see the organization of a 1K into one memory chip is nothing but one data line. You are able to see here the one data line. So 1K is nothing but 1024 memory locations is nothing but 2 to the power of 10 is nothing but 10-bit address lines and one data lines. So along with that, it is going to have 10-bit address lines which is being considered as the 5-bit row addresses, and in 10-bit it is again divided as the 5-bit for addressing the row and 5-bit for addressing particular column. Okay, so this is what the sense and the write circuitry, one more control signal, and a read or write is the another control signal, and the chip selection is the another control signals. Totally 10 plus 1 12 11 12 13 and the 14 control signals. So you are able to see that is 5-bit decoder is nothing but it is going to have the 5-bit decoder is nothing but 2 to the power of 5 is the outcome, is nothing but 32 is the outcome. So totally what is the array here, how many memory cells, that is 32 cross 32. So 32 cross 32 will become 10424 memory locations. So this is how the memory chip can be designed. Okay, so this is for row addressing. You are setting the word length as 32 bit of length, that is nothing but W0 to the W31. So totally it is 32 into 32, 32 rows and 32 columns. So that becomes 1024 memory locations. Okay, so in that particular data, because data input is single, it is a bidirectional single input output data. So being given to the multiplexer. What is multiplexer? A multiplexer and the demultiplexer. Demultiplexer is nothing but it is acting like a decoder. Is nothing but it is going to have the one input and multiple outcome. When you come to the multiplexer, it is going to have multiple inputs and the single output. So this is what happens here. So this is the output multiplexer and input demultiplexer. So input demultiplexer is nothing but it has to generate, that is one data input should be given to it, it has to reach to the 32 memory cells. In that 32 memory cells, particular cell has to be selected. So how the row is going to specify the particular location of the row, and the column address is going to specify particular column in that particular row. So that is going to be done by using the read or write and the chip selection control signals. Okay, so this is about the organization of the 1K cross into one memory chip.